Right, okay, let's get going. We'll start promptly today. Hopefully everyone can hear and see me all right. So welcome to LondonR. A little bit about Mango. We were formed in 2002 and we've recently been acquired by a company called Ascent. Ascent specialise in software solutions, so it's turning out to be a really great partnership between us. We kind of have the data experience and expertise, and they have the software knowledge. We're based in Chippenham, Bristol and London. Obviously at the moment we're all working at home, and we empower organisations to make informed decisions using data science and advanced analytics. We also organise a range of data science events. So we have LondonR, Bristol Data Scientists, Data Engineering London, and we have our flagship conference, which is the Enterprise Applications of the R Language Conference, which takes place once a year in September. I'm going to come on to that in a little bit as well. Of course, we're hiring, as is everybody. So if you'd like to check out the Ascent website, we've got a couple of different roles, kind of data consultant and all that kind of stuff. So take a look there if you're interested. And as I just mentioned, the R conference that is taking place in September this year, we've decided to run it online for obvious reasons. It's just kind of probably going to work out to be, the safer way to do it. So we're going to do a week's worth of workshops. We're going to do four workshops on the 6th to the 9th of September. And then the conference is going to end in a day of presentations with people talking about using R in enterprise. We are currently accepting abstracts for the conference. So if you use R at work and you think you've got an interesting story, please get in touch. We'd love to hear about it. If you visit earlconf.com, you can find out information how you can submit your abstract, and they actually close next week. With LondonR, usually when we're in person, we do a workshop and evening presentations in one go. But at the moment, just, it's difficult for people to get time out of work, and, people don't really want to stay around on the computer after they finish work. So we're just alternating between doing a workshop like we're doing today and then doing the evening presentations. So I think I'm going to organise another evening presentation session for next month. So if you're interested in speaking, please drop me an email at events@mango-solutions.com. It's a really friendly crowd. And then today we have a text analysis in R workshop with Hannah Alexander and Elizabeth Brown. Hannah and Elizabeth are fairly new to Mango, so if everyone could, welcome them to their first LondonR, we're really excited. And also just a bit of housekeeping, just to let you know that this session is being recorded. So if you have your camera on or if you say anything, you are being recorded, and this will be put on our YouTube page to be shared out with the LondonR community. So just to bear that in mind. If you could keep yourself on mute, that would be wonderful. Feel free to have your cameras on. It's nice to see that there's actually people listening rather than a blank screen. And if you have any questions for Hannah and Elizabeth, please use the chat function and they'll be able to respond to you. And if you're enjoying the session, please let us know on Twitter, #LondonR, and we're at Mango the Cat. Right, that is everything from me. So I'm going to stop sharing my screen and hand over to Hannah and Elizabeth. So whenever you're ready, you could take it away.
Oh, sorry, just sharing the screen. Hello, everyone. Can everyone see my screen okay?
Yeah, all good.
All good, brilliant. Okay, so my name's Hannah, and Elizabeth will be helping me throughout this workshop. I'm one of the graduate data scientists at Mango, and Elizabeth's one of the industrial trainees. Hopefully everyone has the materials that were sent around. If not, I'll post the GitHub link in the chat.
I've just pasted.
Oh, you've just done it again. Perfect. And hopefully you've all installed the packages that we're going to be using today, which was also in the email that was sent. These notes will all be provided, so there's no need to copy anything down as I'm going through. I would recommend just listening instead of trying to keep up with everything. And if you have any questions, if you could pop them in the chat and keep yourselves on mute, that would be fantastic. So, welcome to the Text Analysis in R workshop. Today we're going to go through the following topics: analyzing text data in R, tidying and summarizing text data, n-grams and relationships between words, visualizing related words, sentiment analysis using tidy text, the sentiments data frame, producing quantitative results from text, word document frequency, which will include term frequency, inverse document frequency, and applying term frequency, inverse document frequency. So, we all know that in real life, data is usually pretty messy. It doesn't come in a nice format for us to do our analysis as much as we wish it would. So that's why this chapter we're going to go into about how to get the data in a usable format for analysis. And a useful package for this is the tidy text package, which allows us to get text data into a usable format and undertake useful analysis. So I'll pop a title in. So for us to do this, first of all, we need to get some data to work with. So for this, we're going to use the Gutenberg R package. And from this package, we're going to use two functions. One, the Gutenberg works, and the other one being the Gutenberg download. So with the Gutenberg works function, we specify what title that we want to download. So for this workshop, we want to download the wonderful Wizard of Oz. And when we do this, we can see that the ID for this document is 55. So what you do is specify the ID. However, this morning we found out that the way that the Gutenberg package works is it downloads these texts from the Project Gutenberg Mirror. And this morning we found out that's actually down. So we discovered a workaround, which is if we specify this argument here, this mirror argument, it then will work. So Elizabeth's going to post that in the chat for you to also add into your Gutenberg download function, just for the purposes of today. Should normally work, but now in the future, if it doesn't work again, then you know the workaround. So if we then assign this to a, variable, we can see that it's got one row for each line in the text. And this is all great, but it's actually a lot more useful to separate the document into individual words. So to do this, we can tokenize the data using the unnest tokens function. So we and we take the text column from here, and we are saying that we want it to now be made into a word column. So head of tiny wizard. You can see now we have a row for every word that is in the book. So now we've got our data in a more usable format, we can undertake some analysis. So here we're going to count which words are the most frequent in the text. So we will do this using the count function. We take our word column. We want to sort the data frame we produce. So we get the most frequent at the top. And then if we look at the first few rows, we can see the most frequent words. But I'm sure you'll notice that these words are not particularly interesting. No one really cares how often the and are written in a text. So one way to get around this is to remove words. So Tidy Text has an inbuilt data frame called stop words, which is essentially all of these uninteresting words that don't really add anything to an analysis. So if we have a look at this, so yeah, it's just a collection of words that have been defined that's useful for us to have access to. So here, now we can use the anti-join function to remove these words. So if we take our tidy wizard and anti-join words by words, we're using the word column. And if we pipe that then into count again, count the word column, sort was true, and then pipe this in. We can now see that the most common words are in fact the names of the characters. So Dorothy, Scarecrow, Woodman, Lion, Oz, and Tin. So this is a lot more useful. But say, for example, we didn't want to take into account all the names of the characters in the book, as we might have guessed that they were going to be the most commonly said words. What we can do is remove other unwanted content that we can specify. And we do this in a very similar way. We create our own data frame. Specify our word column that we want. I'm just going to paste these in to make my life a bit easier. So we have our characters data frame, and then we do the same thing as before. So we want tidy wizard. With our words. And then we just have characters data frame. Form another anti-join.
Hannah, characters is misspelled.
Would be better. Amazing, thank you. So if we take a look at our new data frame, we can see that our most frequent words are Oz, Greendale, Head City, answered. So if we want to refine this analysis even further, we can, well, it's important to consider words that maybe aren't the same, but they essentially mean the same thing. So they cover the same stem words. So for example, fearing, fearsome, feared, they all mean fear, but they would be counted separately since they are actually different words. So a package that allows us to account for that is Snowball C. So Snowball C has a package called word stems. So if we use this on fear, fearing, fickle, play, played, but played, playing, you can see that this then reduces them down to fear, play. So we can then modify our data frame again. So remove our stop words. And then we mutate our word column to word stem, using word stem, sorry. And then we can count the frequency of each word.
Hannah,
Yeah?
your sound is cutting out sometimes.
Oh no, where should I repeat from?
I'm not sure, I think it just sort of
Me.
sometimes happens sporadic, like unpredictably.
Okay, let me know if it happens for like a substantial amount of time. Yeah, I don't know why that's happening. We've never had that before. But okay, well, let me know if anything's not clear. Ask more questions if you like something important cuts out over. So, should I recap over was that bit clear with the stemming? Elizabeth?
The sound is going off when you're typing, so maybe just go through that bit again, just for clarity, with the Snowball C.
Okay, so if we want to get the stem of words, we can use a package called Snowball C. So when I ran stem on this list, it modified it to just the stems of those words. So fear, play. And then if we do the same thing here on our Tidy Wizard data set, here we do the anti-join to get rid of the stop words, then we mutate the word column. So all the words will just go down to their stems, and then we can recount the words again to find the most common ones. So if we do the head, that's not what I should do. Not sure.
sort equal true in count.
Oh, perfect. Thank you. That would be why. There we go. Amazing. So, I mean, in this situation, it hasn't actually made any difference to the most common words because they're names. But if we look further in the text, there may be cases where, yeah, that's made a difference to the frequency of certain words. So now we come on to an exercise. Bring this in. So I'll give you maybe 7 minutes. So if you come back on the hour, and then I'll go through the exercise. And feel free to ask more questions if anything's not clear. But yeah, me and Elizabeth will be here to answer any questions you have. So what is best for everyone for me to do? Should I just type and then speak when I'm not typing?
I think that would be best. Yeah, if you already have the code, then maybe just copy and paste and then talk about it.
Okay. So I'm probably butchering your name, I'm very sorry. Romold, saying your error, have you set so have you set mirror to the URL that we posted in the chat? I can post it again if that's okay, great. So if no one has any questions, I'll quickly run through the answers and talk you through it. I'll copy and paste them in instead of typing them, and then talk you through it. As I've found out, me typing and talking isn't working today. Okay, so first of all, first exercise. Yeah, extract the Treasure Island text from the Gutenberg R Public Library and tidy the book into the tidy one token per row structure. So we'll start by librarying in the packages that we need, and then searching the Gutenberg works for the Treasure Island package, and then assigning, downloading the title using the Gutenberg ID to a Treasure Island variable. So in this case, we will need to add mirror in. Okay. If we do so, this gives an idea of 120. So we've got 120 in there. Downloaded the text. So now we can see these are the lines of our Treasure Island. And now here we use the nest function on the text column to produce a word column. And then if we go ahead at that, we can get one word per row. Part 2 is find the most common words in the Treasure Island text. To do this, we type the tidy Treasure Island into count. And then again, we just have our stop words being the most frequent. Part 3, what are the most common words after removing the stop words? So yeah, here we use an anti-join to remove the stop words in the Treasure Island data set, and then we count the words and sort them so we get the most frequent at the top. So you can see that Captain, Silver, Doctor, Han, C are most frequent. And then finally, stem the Treasure Island text. And does this change the order of the most common words in the text? So the library and snowball. And then we, here we take our word column and mutate it using word stem. Again, sorting everything. We see the head, and now we can see that our most frequent is now hand instead of captain. Okay, so I'll just quickly look in the chat. Oh, I see. Yes, thank you for realising the mirrors depend on the country. Okay, so next up we are going to go on to n-grams and relationships between words. Cool, so instead of looking at just individual words, sometimes it can be useful to get pairs or groups of words, as this provides us with a better understanding of the relationship between words. So in order to do this, we can use n-grams. So we use the tokenization like we did before, but this time, instead of using, or we add an argument called token and assign it to n-grams. So here we have our Tidy Wizard n-gram argument. We take the Wizard of Oz that we got from the Gutenberg R package. We unnest the tokens, taking our text column, converting it into a word column, and assign token is n-grams and n equals 2 because we will look at 5 grams. Okay, it's because I've got capitalized it the same. Right, so now if we want to count for our most frequent n-grams, we can use count as we did before. So here we're piping the wizard n-grams into count. And here we can see the most frequent is of the scarecrow to the and the said the. So here it can be really useful to separate the words out into a first word and second word, as this allows us to remove unwanted words like our stop words. So if we start from the beginning, we take our Wizard of Oz, we unnest the tokens using n-grams, we count them, and then we separate them into first word and second word columns, and we're separating on the space between the words. If we do ahead, Wizard n-gram, you can see that now we have 2 columns, first word and second word. So now we can remove our stop words. So we take our Tidy Wizard n-gram, we do an anti-join, and here we do the stop words for every stop word in our first word column, and then we do it again for our second word column. And now if we do ahead of that, we can see we get something a lot more useful. That our most common biograms are tin, woodman, wicked witch, emerald city, winged monkeys, and aunt M. So next we're going to go on to visualizing related words. Because yeah, visualizing words can be very useful. It's just got a very quick way of getting across information. So we can do this using a network plot of the most common words associated with different characters. So again, I'll copy and paste this in. So we library in the packages we need, Ggraph, iGraph, and TidyR. Again, we're going through unnesting the tokens to create the bigrams, counting the frequency of each word and then separating them into first word and second word columns. Then we want to remove the stop words, just like how we've just done. And then we want to filter for this example. So we just get the first words that are related to either Dorothy or the Scarecrow. And the second words that are related to only Dorothy or the Scarecrow. So if I run this all the way through, see now that we just have bigrams that are related to Dorothy or the Scarecrow. So from this, we can use a function from iGraph called graph from data frame, which essentially creates a matrix of links between different words. So if I show you on here, basically the matrix is created where 1 means that the words are linked and 0 means the words aren't linked. So it's just a big matrix of all the words and whether they're linked or not. And right. So I do the head of graph wizard. You can see what I mean by this being essentially the row names are the same as the column names. But you can see that what is linked with what. And then once we have this iGraph object, we can use the Ggraph function. Run this. Yeah, so we get a network that looks like this. So Dorothy is connected to these words, and the thicker the line, the more that the higher the connection between the two words. So this is done by, we take the iGraph wizard that we created, we use the stress layout, which essentially just makes everything be forced away from each other. We add our edges, and the edge alpha is the thickness of each line, and this is dependent on n, so that's the frequency. And then we add node points, and the color we've chosen is coral, the size is 3, and the text for each node. And that's just going to be the name of the word. So yeah, and this brings us on to another exercise. So I'll give us until 20 past to do that exercise. It is so tokenize the Treasure Island data into word triplets and which words co-occur most frequently. Thank you, Elizabeth, for answering everything in the chat. Okay, so if no one has any immediate questions, I'll go through the answers. So question 1 is tokenize the treasure island data into word triplets or trigrams. So, oh wait, I'll scroll it up and get my mirror URL. So we know from previously that the Gutenberg download ID for Treasure Island is 120, so we'll pop it in the URL. So we download that, and then do unlist tokens with token n-grams and set n to equal 3. And if we look at the head of that, we get our trigrams. And then the next question is which words co-occur most frequently. To do that, we do a count on the data frame we just made, and we can view the head of that. We can see that out of there, one of there, so the captain, I began to, and at the same, are the most frequently used trigrams. Of course, if you wanted to go further and you wanted to remove the stop words, then you could do that as we did previously. This time you'd have to separate them into 3 columns instead of 2, like last time, because it's trigrams this time, but the principle would be the same. Cool. So if there's no, is there a reason why n is set to 3? Yes, because in this situation we're looking at trigrams, so we want to see occurrence. The most frequent occurrences where 3 of the same words occur together. So before we looked at bigrams, so we set n to 2 because we just wanted to see where there were 2 words together. But this time we wanted to see when 3 words were written consecutively and which were the most frequently consecutively 3 words in a row selection of words, if that makes sense. That's a good question. I'm not sure why there's so many NAs. I think it is just spaces in the text document. I don't know if Elizabeth, you could have a Google. I'm pretty sure that's what that is, just like here. So imagine like the first page of a book. There's quite a lot of blank text, and it'll just say like by this person. But perhaps R is still counting that as a row. I'm not completely sure, but if Elizabeth had a little Google, see if she can find anything. But you can just drop them with drop NA. Okay, so, actually what I'll do, now we're about halfway, I think, so if we want to take a little break, say we'll come at 32, so give you just under 10 minutes. I realise I haven't given anyone a break yet, so yeah, if we all come back and I'll start again at 32 past. Okay, cool. So I think we'll start again. Hopefully everyone's back. Might give a few more seconds. Is everyone finding the pace okay and everything? Let's check. I think we're pretty good for time. I think we're about, yeah, we're a good halfway and halfway through the time, so pretty perfect. Oh, hello, someone has a question. So Kamal, do you mean the like the network graph that we produced? Okay, so it's essentially each node, when it's connected to, the connections are if it's connected to the other nodes. So when we did bigrams, if one word was said next to another word, that means that they're connected. And the number of times that they were repeated next to each other is how frequently they were connected. And that's what determines how thick each line is. I don't know if that answers your question. Amazing, great. Cool, okay, so next up we're going to go into some sentiment analysis. So sentiment analysis is really great for just really quickly getting a general feel of a document or some text. And we can do this by using the get sentiments function from the tidy text package. So this function basically returns so sentiment lexicons in an already tidy format, which we can join with our one word per row data sets that we make. So by lexicons, I mean it's a selection of predefined words like our stop words. So for example, there is different sentiment lexicons. One's called Bing, one's called a Thin, and they all, I guess, define sentiment slightly differently. And I'll kind of go on to that as we go through the exercise. So we'll take our Wizard of Oz text again and tidy it up as we've done before. We've got our most common words again. And then if we use the get sentiment function, we can essentially see what the get sentiments lexicon equals Bing does is it produces a really long list of words and a sentiment associated with each one, either positive or negative. Sorry, someone just parked outside my window playing really loud music. I'm just going to close it. Sorry about that. Yeah, so then what we can do with this data frame that we produce is connect it with our previous data frame that we created, the one with our most common words, so we can get a feel of how positive or negative our text might be. So we can do this using an inner join. So what I've done here is I piped a tidy wizard data frame into the inner join function alongside our sentiment data frame, and we're joining them by the word column. And this has produced our just our words, and then alongside it, how frequently they're in the text and if they're considered to be negative or positive. And then from this, it's possible to determine if the Wizard of Oz is overall a positive or a negative text. So yeah, as before, we've got inner join, and if we group by sentiments, so group by, have a group where only the words are negative and a group where they're only positive, and then use the summarize function and create the sums of the different groups. We have our negative words are said 1,105 times, and positive words are said 840 times. So you can see that the text is a little bit more negative than positive overall. And this is all well and good, but if we want slightly more quantitative results, we can use a different sentiment. So the get sentiment function has a lexicon called a fin, and this essentially produces a number alongside of a number from -5 to 5 to determine how negative or positive a word is, instead of just negative or positive. And I'll use that in the next example. So next, what we're going to do is assess how negative and positive the text is throughout the storyline. So we're going to do this by using the, we're going to use the this notation to essentially split the lines into different sections. So we get analysis for different sections of the book instead of each individual line. So first of all, to do this, we're going to create a line number onto our Wizard of Oz data frame, and then we're going to take the text column, put it into word columns as before, remove the stop words, do an inner join using the fin package, fin lexicon. So I'll show you what that looks like if I run it. Load. Yeah, so this time instead of negative or positive, we get a value. So 4 is pretty positive, and then 2 is like kind of a bit positive, and -2 is a bit negative. Cool. So next, what we want to do is split our book into sections using the line number we just created. So here we're going to add a book section column using line number and dividing this line number into 100 sections of 100. And then we're going to group the data set into each section and then summarize each section of its positive or negativeness, its sentiment. Now if we look ahead of this, we get different book sections and how positive or negative it is. So we can see that it starts pretty positive, and then something really bad happens and it gets a bit negative. Then we kind of stay in the middle, and something really bad happens, and then it gets really negative, and then we get positive towards the end again. So now we can visualize this. using Ggplot. So we take our affine wizard dataset, we use the aesthetic parameter, having book section as our X, score as our Y, gym line, gym point, and then add our title and our Y axis labels. So we can see that. Yeah, I'll describe we start fairly positive and it gradually goes down. And then it goes back up again. And then another travesty happens. And we go back up. And yeah, then we're pretty, yeah, that's like you can kind of see how the plot changes throughout the book. And this brings us on to an exercise. So I guess I'll give you guys until 10 to do that. If you've got any questions. Oh, that is a great question, Paul. There are ones for other languages. If you, while you do this exercise, sorry, I just showed it in chat. I will quickly go through and I'll have a look online, but it's somewhere because I have seen it before. Cool. So if at about 10 to, I'll run through the answers. So if no one's got any more questions, I will let you get on with the exercise. So I've had a little Google and I can't find a ton actually about lexicons on other languages. I think it's an area that's being developed and there isn't many as of yet. I found a web page in this chat that talks about it a bit that might be helpful. I'll also do some more research after this and in an email afterwards. If I find anything, I will let you know. But I think this page has a bit on just the development of lexicons in different languages. So cool. If there's no other questions, I will get on with the answers for this part. Okay. Okay, so part one. What are the most frequently used positive words in Treasure Island? So we start off by downloading the package, library and the packages that we need. Gutenberg R, Tidy Text, Tidy Verse. Again, as before, getting our Gutenberg R package, adding in the mirror argument. And then we unnest the tokens as before, do an anti-join, throw in the stop words, and count the most frequent words. Then we get our sentiment lexicon. And then we do an inner join, find our most positive or negative words. So this is our inner join on our word column. And then we are arranging our column to get the most frequent the occurring words first. And then part two is the Treasure Island text, mostly positive or negative. So we take our Treasure Island text, do an inner join on sentiment by word, group by the sentiment, summarize. So we can see that we've got more negative words, almost double, than positive words. We can also do this using a different lexicon. So using affin instead to get a more quantitative output. So here we can see that overall we've got a value of minus 1,174. So here what we've done is an inner join on the sentiments using affin, inner join on the word column. Then we've mutated, getting a total score of the frequency of the word occurring and the value of that word. So the lexicon value that it's given, depending on how positive or negative it is. And then we have a final total, which is just that total score column added up. And then third part is then our third part is how does sentiment change throughout the Treasure Island text? So we've got Treasure Island text, and I've sectioned it into multiple sections throughout the book. So we've got our line number column, we have nested the tokens to take our text column into individual words. We've done an anti-join to remove the stop words. We've done an inner join on our sentiments. So using the get sentiment lexicon equals a fin to get a number. And then we've added a book section column, which is the line number split into 100 to get our book into sections. Yeah, so we've got our line number in our book section, which we can't see. And then now we have our grouping by the book section, summarizing, so getting the mean value for each section, and then plotting the book section versus the average sentiment for each section, and then using Ggplot to get a geom1, geom1, geom smooth. So, as you can see, this is the general trend, just the general up, general down, back up. And then you can see a more granular approach. The points reported for each section. Is there any questions? So to Marie's question, I think I would do what she suggested. I'll try and think if there's a better way, but Marie's asked, is there a way we can take into account the negation in text, i.e. if great used a lot, it's classified as positive, but if it's not great, then it's classified as negative. Yeah, I would keep in the stop words and use bigrams to try and search for those words. I try and think there's a better alternative, but yeah, using any of these approaches, they're not perfect. There will be like anomalies that are picked up wrong, but I think if there's a large text, then the amount that's used is probably, yeah. And then what Elizabeth says, TD and IDF kind of like removes the issue of your like in the imperfections in stop words. Yeah, so we'll come to that. Basically, if something's not being used that often, it kind of stops it from having any influence, really. Cool, so there's no more questions. I'll move on to the next section, which is word clouds. So word clouds is a really good way of visualizing keywords in a data set. So we can do that using the word cloud function, which takes two main arguments, the words to include and the count of their frequency. So if we library in the word cloud library and define a cloud wizard variable using the Wizard of Oz data, again, as before, unnest the tokens, remove the stop words, count their frequency. And if we pop these into the word cloud function, yeah, there we go. See, this produces this nice little word cloud. So you can see that our most frequent words are scarecrow, lion, Oz, tin. Yeah. And in the code itself, what we do is our words are cloud, the word column from the Wizard of Oz dataset that we made, frequency is the end column from the Cloud Wizard data frame that we made, as I suppose the maximum number of words that we want to include in this word cloud is 50, and the colour we want to use is coral. So we could also use word clouds to do comparisons, for example, between words in different documents. So in this situation, we're going to do it by comparing the positive and the negative words in the text. And to do this, we need to put our data frame into a term frequency matrix, which is a little bit fiddly, but it's worth it. So essentially we need it in this format. So we have our two groups, negative and positive, and our words, and we want how frequent that occurs. So how frequent this word is positive and how frequent this word is negative. And because it's binary, it will either be a negative or a positive word in this situation. That's why it would be 0 otherwise. But you could do it for other cases. Yeah, why it will not be so binary. But yes, this is what we're aiming for. So yeah, here we take our Wizard of Oz data, we unnest the tokens, anti-join, inner join on the Bing sentiments. That's why it's binary, it's just going to be positive or negative in this situation. And then we count the word column based on the sentiment. So how often it's positive, how often it's negative. And then we sort them pivot wider so we get it in the correct format with our positive, negative as our column names and our words as our row names. And then we need to turn it into a data frame because yeah, the like a tibble, sorry, doesn't support doesn't support row names, sorry. So we have to convert our data back into a data frame. So I run this. Yep. And now once we have this, we can set words to row names. Yeah. Head. You can see now we've got negative, positive, and then the names of the words and how frequently they're negative and how frequently they're positive. And then in order to plot this, we use a function called comparison cloud. Okay, yeah, this doesn't. There we go, that's a bit better. So now we can see that these are all our negative words and these are all our positive words. And the size again is determined on how frequently that they're there. Okay, now on to another exercise. I might just give you 5 minutes for this one because we're getting near the end on time. So yeah, make 2 word clouds, one using positive and the other using negative sentiment words for Treasure Island, and then combine and compare the 2 clouds. So just as we've just done. Okay, cool. I'll give you at 9 past, I'll go through the answers. anyone has any more questions, I will get on with the answers now. Oops. So part 1, make 2 word clouds, one using positive and the other using negative sentiment from the Treasure Island text. So first we get our Treasure Island text as before, unnest the tokens, get rid of the stop words, count the frequency, do an inner join based on with the get sentiments lexicon as Bing, and join them on the word. So here we've got our words, our frequency, and its sentiment. So next we will filter our Treasure Island sentiment for just negative words. And then do a word cloud just based on this. So we just take our Treasure Island negative, the word column, Treasure Island negative, then the frequency column. We want 50 words maximum, and we want the colors to be dark red. So if I whoops. Cool. So here's all our words and the size how frequent they are. And then we can do this again for our positive values. So take our Treasure Island sentiment and just filter for them being positive, and do a word cloud in exactly the same way. Here we have the same thing, our word cloud in green this time. Yeah. And then for the second part, combine and compare the 2 clouds. We take our Treasure Island sentiment, we convert it to a data frame, and then we do the cloud based on the word. Oh yeah, sorry. So here we're assigning the row names to the comp cloud because we couldn't before because it was a tibble. But now we've converted it back to a data frame, and we've given the row names which are the words from our data frame. And then here we have, because now we've added it to our rows, we don't want it as a column, so we're minusing that word column out of our comp cloud data frame. So now we have our comp cloud data frame with just our row names are the words, and we've got negative and positive. So we've got it back into the format essentially we were trying to get it in before. We've got it back into this term frequency matrix. And then if we do the comparison cloud, we put our comp cloud in, and we want the colors to be dark red and dark green. and with the maximum of 50 words. So there we go. Okay, I'm quickly going to now go on to Word document frequency. So we're now doing criteria here. Basically, finding the most important word in a text is useful in getting a quick summary, but the most frequent words can be effective, but this is limited by the quality of the stop words, as we kind of discussed before in the chat. But in TD IDF, it can pick out keywords in a given document compared to a set of documents. So essentially, if a word is really, really frequent, like stop words, the IDF will be 0. So we can take that into account and just ignore it, because there will be a certain number of documents and there will be a very high percentage of those documents will have that word in. Yeah, so our term frequency is the number of times a term appears in a document over the total number of terms in the document, and the inverse document frequency is the log of the number of documents over the number of documents with the term in. So this sort of analysis can be undertaken using the find TF IDF function from tidytext, and for it to work, the data needs to be in a tidy form, and we need to count the word frequency. So as before, we will take our Wizard of Oz data and we are going to, because we don't have lots of documents in this situation, we're going to split the Wizard of Oz data into multiple sections like we did before. So we're going to add a line number and split the lines into individual words. Oh, whoops. Nope. So lucky. There we go. And now we're going to split the book into every 1,000 lines to get a book section. And we can add a document term count. So we group by the book section, summarize by making the count the number of times the words occurred, ungroup, and then arrange by the negative count. So now if I do that, you can see we have the words, the book section, and the count. So now you can see that there's a lot of thirds and ands in this. So we can, so first you can see the book section, and then this is the count for that book section. So that's why that is there 5 times. So now we can apply TF IDF, and we can sort of show why it doesn't matter that we haven't removed our stop words. So if we do that, we can now see that our TFs are are very small. So this kind of eliminates the need for any stop words. Okay, so finally, if we want to visualize these results, we can see which words are most indicative of each section. And one way to do this is to plot the words with the highest TF IDF for each book section. So we take our Tidy Wizards data set, grouped by the book section that we've made. We just filter it for our top 6 words with the highest TF IDF. Then we use Ggplot to we're essentially creating we use Ggplot to plot individual plots for each section based on the TF IDF and the word. And then you take our and then we do the facet wrap. So we do it for each book section with 2 columns, and then we, yeah. Okay. I'm not sure that's not working. I'm sure it worked the last time I ran it. Elizabeth, I don't know if you can see anything.
Someone in the chat has just suggested trying and run dev.auth backwards
Whoops.
and then running the code after it.
I think that has worked.
Thank you.
Thank you, whoever suggested that. Okay, cool. And now we have for each section of the book that we find, we have the 6 most frequent words and their TF IDF value. Okay, so now we've got one final exercise. I don't want to keep you all, so what I might do is just run through it. Yeah, I think that might be best. And then if anyone has any questions, just quickly go through them at the very end. My goodness. Okay, so for part 1, split the treasure island text into several sections. and then manipulate it to the form required for the TF-IDF analysis. So we've libraried in the datasets we need, got our Treasure Island text, mutated it, and adding a book section that's based on the row number divided by 1,000. Now we've unnested the tokens, so taken our text columns and split them into individual words, counted the frequency for each book section, and then arranged by negative frequency. Head. You can see we've got it each word, each section, and how frequent they are. Part 2, find the TF-IDF for the words in Treasure Island by book section. So we got Tidy Island data, use the find TF-IDF. Term is the word column, and then the document is the book section column, and N is what we've defined as N, and that's the frequency. So if we run that, you can see we then get a TF-IDF for each of the words. Yeah, and an IDF of 0, that essentially means that it occurs in every single document. So they're likely to be your stock words. And then finally, visualize your results. We group by the book section. We take our top 6 highest TF-IDF words. We then plot for each section. We plot our word against our TF-IDF. We split this into book sections. We have, and we format this so we have 2 columns of graphs. And yeah, there we go. Put your graphs of for each section. Here's your words, and then here's your TF-IDF. Okay, great. So if anyone has any further questions. Sharing that. I'll give it a couple of minutes in case anyone's typing. No? Okay then. In which case, thank you for coming, everyone. Hope you learned something. Yeah, I'll pass back to Laura now.
Great. Thank you so much, Hannah and Elizabeth. That was brilliant. I will try and get the recording of this out tomorrow, so keep an eye on your inboxes for that. And probably plan a next LondonR for next month. So thank you so much for joining, everybody. And yeah, cheers. Have a nice evening. Thanks.
Thank you, everyone.
Hi, I have a quick question. Is that okay?
Yeah, of course.
So I'm just going to cut the music in the background. You know, on the scripts you put on GitHub, there's some modeling later with BBC files, and the files are not on GitHub, and I was quite keen on trying this. Is there a way to get the files, please?
I'm a bit confused. Maybe you have a different. Oh no, my laptop's freezing. The GitHub link that I'm on doesn't have any BBC files.
No, it doesn't have BBC files, but the scripts there goes further into topic
Oh, I
modeling.
see what you mean. Is that in all materials?
Yeah, possibly. But I was actually quite keen on the other material.
Okay, I think we probably could give them to you. Yeah, I don't see why not. We do have them. It was just one of the parts that I removed to fit it all in the time frame. But yeah, I'm sure they'll be around afterwards.
I think I found the Mango training web link. Thank you. Because I found another one and it wasn't working. Excellent, thanks, Alex. Yeah, cool. I think I have possibly found. Let me install the package quick. Yeah, there's BBC Politic 1, 2, 3 RDA, so I can work with that instead. Okay, don't worry. I'll manage. Thanks a lot.
Great. Thank you.
Thank you.
If that is everything, I will end the meeting. Cool. Thanks, everyone.